Bismillahirrahmanirrahim. We are discussing second year mathematics. In this video, we will discuss exercise 6.2. The first question is evaluate the following indefinite integrals by the method of substitution. Now we have the first question, question A, part first, integral of sine power 4 of x cos of x d of x. So he said that simplify these integrals with the help of substitution. So first of all, let u is equal to sine of x. You can also let it t is equal to sine of x. You can also let y is equal to sine of x. Z is equal to sine of x. So taking derivative on both sides with respect to x, du divided by dx is equal to d divided by dx sine of x. So this will become du divided by dx is equal to the derivative of sine is cos of x. So this will become du is equal to cos of x dot dx. So cos of x d of x is equal to du and sine of x is equal to u. So at the place of cos of x d of x, I can write du, and at the place of sine x, I can write u. So this will become integral of u power 4 dot du. So this will become this is equal to u power 4 plus 1 and 4 plus 1 plus c, and this is equal to u power 5 divided by 5 plus c. So put the value of u, which is sine of x. So sine power 5 divided by 5 plus c. So this is our answer. So you can also simplify this with simple method. If it is not written that solve it with the help of substitution, you can directly solve it at like this. If you have this one, sine power x cos of x dx, we know that if we have this type of situation, if you have f of x and here you have f prime of x and here this is power n and f of x power n, and here you have f of x and dx. So the integral of this one will become f of x whole power n plus 1 divided by n plus 1. So here this is f of x and it is f prime of x. So f of x n plus 1 5 and n plus 1. So this will become. So now we will discuss part B of question number 1. So part B of the question number 1, part B. So cube root of sine square x cos of x d of x integral of. So I can solve it at this will become integral of sine square x whole power 1 divided by 3 cos of x d of x. So this will become integral of sine of x whole power 2 divided by 3 cos of x d of x. Now let u is equal to sine of x. Taking derivative on both sides, du divided by dx is equal to cos of x, which implies that du is equal to cos of x d of x. So at the place of cos of x d of x, I can write du, and at the place of this one I can write u. So this will become u power 2 divided by 3 du. So this will become u 2 divided by 3 plus 1 divided by 2 divided by 3 plus 1 plus c. So this will become u power 5 divided by 3, and this will become 5 here and 3 here plus c. So simply put the value of u, which is sine of x. So 3 sine power 5 divided by 3x divided by 5 plus c. So this is our answer. Now we will discuss next part. So part number C, question number 1. So sine of x, natural log of cos of x d of x divided by cos of x. Now I can rearrange this one as integral of natural log of cos of x sine of x cos of x dot dx. Now let u is equal to natural log of cos of x du divided by dx is equal to 1 divided by cos of x, and derivative of cos of x is minus sine of x. So this will become minus sine of x divided by cos of x. So this is equal to minus du is equal to sine of x divided by cos of x dot dx. So at the place of this one I can write minus du, and at the place of this one I can write u. So this will become u dot minus du, which is equal to minus u du, and this is equal to u2 divided by 2 plus c. Simply put the value of u, which is natural log of cos of x whole square divided by 2 plus c. So this is our answer. Now we will discuss part D of the question. Part D of the question is D part e of x sine of e of x dx. I can write it as sine of e power x dot e power x dx. So this will become, let e of x is equal to u, and d e power x dx is equal to du divided by dx. So du divided by dx is equal to e power x. So du is equal to e power x dx, and at the place of e power x and dx I can write du, and here I can write u. So this will become sine of u dot du, which is equal to if you take the derivative of cos of x, if you take the derivative of cos of x, this is equal to minus sine x. When you take the derivative of minus sine cos of x minus sine minus cos of x, so this will become plus sine of x. So the integral of this one is equal to minus cos of u plus c. So this will become minus cos of e power x plus c. Now we will discuss next part. Now the next part is e part cot of under root x dot dx divided by under root x integral of. So let u is equal to under root x. So du divided by dx is equal to 1 divided by 2 under root x. So this will become du 2 is equal to 1 divided by under root x into d of x. At the place of this one I can write this one. So this is equal to cot of u dot 2 du, which is equal to 2 cot of u du. So this is equal to 2 this is equal to the cos of u divided by sine of u. So this is equal to this one. So we know that we have a formula. We have a formula like this one. If you have this kind of situation, f of x, here you have f of x, and here you have f prime of x dot dx. The integral of this one is natural log of f of x. Okay, so when you have this f of x and here you have f prime of x, derivative of f of x, then the derivative of this one is equal to natural log of f of x. This is sine of u and this is cos of u. When you take the derivative of sine of x, you will get cos of x. Okay, when you take the derivative of sine of u, you will get cos of u. So this is equal to, natural log of sine of u plus c. So the value of u is under root x. So 2 natural log of sine of under root x plus c. So this is our final answer. Now we will discuss the last part. Now question number 1, part number F. So we have the question, sine of x minus cos of x, sine of x plus cos of x dot dx. So this is equal to, let u is equal to sine of x plus cos of x. So this will become du divided by dx is equal to, the derivative of sine of x is cos of x and the derivative of cos of x is minus sine x. So we can write it as du is equal to cos of x minus sine of x whole dx. Now taking minus sign as a common, so this will become du is equal to minus common minus cos of x plus sine of x dx. So this will become du is equal to minus here, and this will become sine of x minus cos of x d of x. So at the place of this one I can write minus du, and at the place of this one I can write u. So this will become du minus du divided by, this is equal to u, this is equal to minus 1 divided by u du. So this is equal to minus natural log of u plus c. The value of u is sine of x plus cos of x. So this will become minus sine of x plus cos of x. So this is our final answer. Now we will discuss question number 2. Question number 2. Now we have question number 2, part 1. D of x, x square plus 16, x square plus 16. Now we can write it as d of x, x square plus 4 square. Here we can let x is equal to, let x is equal to 4 tan of theta. So taking derivative of this one on both sides, so this will become dx dx divided by dx. So this is equal to 4 dot secant square theta d theta divided by dx. So this is equal to 1 4 secant square theta d theta divided by dx. So at the place of dx, so this is equal to dx is equal to 4 secant square theta dot d theta, and at the place of dx I can write this one, and at the place of x I can write this one. So this will become, dx is equal to 4 secant square theta d theta, and this will become 4 tan theta whole square plus 4 square. So this will become, 4 common secant square theta dot d theta, and 4 square 16 tan square theta plus 16. So this is equal to 16 as a common 4 divided by 16. So this will become, secant square theta, and this is equal to tan square theta plus 1, and we know that tan square theta plus 1 is equal to secant theta, and this is equal to 1, and this is 4 1 divided by 4, and this is equal to integral of secant square theta, and this is equal to secant square theta dot d theta, and this will become 1 divided by 4 integral of d theta, and this is equal to 1 divided by 4 theta plus c. So we know that here we have this kind of situation, and which implies that x divided by 4 is equal to tan of theta, which implies that theta is equal to tan inverse of x divided by 4. So at the place of theta put the value 1 divided by 4, theta is equal to tan inverse of x divided by 4 plus c. So this is our answer. So when you have x square plus this a square, then you can let x is equal to, when you have this kind of situation, dx x square plus a square. In this kind of situation, you have to let x is equal to a tan theta. Okay, when you have this one plus this one plus, and this is x square, this is a square, x square plus a square, you have to let x is equal to a tan theta. So here I let x is equal to a tan theta. Okay, now we will discuss second part of the question. You can also solve this question by letting it to some other. I can also solve it with another method. So the next method is, I can solve it with another method. If you have this one, dx x square plus 16, when you have this kind of situation, then you have to let x is equal to, u is equal to x divided by a. So this is equal to dx x square plus 4 square. By comparing this one with this one, dx x square plus a square, here a is equal to 4 and x is equal to x. So when you have this kind of situation, you also let it as u is equal to, x divided by a. Here x is equal to x and a is equal to 4. U is equal to x divided by 4. So this is equal to du divided by dx is equal to 1 divided by 4 So when you take the derivative of this one, this will become 1 divided by 4, and this is equal to du is equal to 1 divided by 4 dx, and 4 du is equal to dx. Now putting the values in the equation, you have uh, this will become, here u is equal to x divided by a, which implies that x is equal to a u. So this is equal to, and this, in this situation, x is equal to 4 u, and this is equal to, at the place of dx I can write 4 du, and at the place of this one I can write 4 square u square plus 16. So this is equal to 4 common, 4 square common 16, so this will become 1 divided by u square plus 1 dot du. So this is equal to 1, this is equal to 4, so this is equal to 1 divided by u square plus 1 plus c. So this, sorry, when you take the derivative of sine tan inverse of u, will get this one. So this is equal to tan inverse of u plus c. So put the value of u, which is equal to x divided by a. So tan inverse x divided by a plus c. So you can solve it at, by letting u is equal to x divided by a, or you can also solve it at x is equal to a tan theta. So we have next question, sine of x divided by cos square x plus 1 divided by d of x. So simply let u is equal to cos of x. Okay, so du divided by dx is equal to minus sine x. So du is equal to minus sine x divided by dx. So this will become minus du is equal to sine of x dx. At the place of sine of x dx I can write minus du, and at the place of cos square x I can write u square plus 1. So this is equal to minus du divided by u square plus 1. We know that u square plus 1 is equal to minus tan inverse of u plus c, and u is equal to cos of x. So this is equal to minus tan inverse of cos of x plus c. So this is the answer. Now we will discuss next part. Next part we have C part of question number 2, d of x under root e power 2x minus 4. So we have to solve this question. So let this is equal to, we can write it as integral of d of x under root e power x 2 minus 4. So this will become, let u is equal to e power x, and du divided by dx is equal to e power x, and du is equal to e power x dot dx, e power x dot dx. So put the value of this one, So this will become du divided by e power x dx. We know that e power x is equal to u. So which implies that du divided by u is equal to dx. So at the place of dx, I can write du divided by u, and at the place of this, I can write u. So this will become du divided by u under root u square minus 2 square. So this is equal to, the integral of this one is equal to secant inverse of, this is equal to secant inverse of u, secant inverse of u divided by 2, u divided by 2 plus c. So put the value of u, secant inverse of u is equal to e power x divided by 2 plus c. So this is our final answer. Now we will discuss next part of the question. Next part of the question is D part. 2x plus 5 divided by x square plus 4x plus 5 d of x. Now we will solve this one. So this is equal to so this is equal to 2 of x plus 4 plus 1, and this is equal to x square plus 4x plus 4 plus 1 dot dx. So this will become 2 common, x plus 2 plus 1 divided by, so this is x plus 2 whole square, x plus 2 whole square plus 1 dx. So this is equal to, I can write it as 2x plus 2 divided by x plus 2 whole square plus 1 and plus 1 divided by x plus 2 whole square plus 1 dx, and here also dx, integral of this one, and I split this one into its fractions. So next we will let x plus 2 is equal to u, x plus 2 is equal to u. So this will become let u is equal to x plus 2. So this will become taking derivative du divided by dx is equal to 1. So du is equal to dx. At the place of dx, I can write du. So this will become 2 common. Here 2 is I can write 2 outside, and this is equal to x plus 2 is equal to u. This is equal to u square plus 1, and this is equal to du, and plus this is equal to u square plus 1 dot du, and we have the formula. If you have f prime of x here, and here you have f of x, and this is equal to natural log of f of x. Okay, so when you take the derivative of this one, you will get this one. So this is equal to natural log of u square plus 1, and this is equal to tan inverse of, this is equal to tan inverse of u plus c. Now putting the values, and u is equal to x plus 2 natural log of x plus 2 whole square plus 1, and this is equal to tan inverse of x plus 2 plus c. So this is our final answer. Now we will discuss last part of the question. So we have the last part of the question, this one. This is equal to integral of 2 plus x 4 minus 2x minus x square dot dx. Now we will solve this one. So I can write it as 2 plus x and 4 minus common 2x plus x square. So I can d of x. So this is equal to 2 plus x and 4 minus 2x plus x square plus 1 minus 1. So dot d of x. So this is equal to 2 of x 4 minus. So this is equal to 2x plus 1 whole square, and this is equal to minus 1. So this is equal to 2 plus x 4 minus 2x plus 1 whole square plus 1 dx. So this is equal to 4 plus 1 5. Here this is under root, sorry, this is under root, this is also under root, this here is under root, this is under root, and this is written in under root. So this is equal to 1 plus 4 5, 2 plus x 5 minus 2x plus 1 whole square dot d of x under the root and integral. Now here x plus 1 whole square, sorry, this is x plus, only x plus 1, this is only x plus 1, x plus 1, x plus 1. So this is equal to now let x plus 1 is equal to t. Now I can write, so this we have 2 plus x divided by 5 minus x plus 1 whole square under the root d of x. I can write this to 1 plus 1. So 1 plus 1 plus x divided by 5 minus x plus 1 whole square under the root d of x integral. So I can write it as 1 divided by under root 5 minus x plus 1 whole square dx plus 1 plus x 5 minus x plus 1 whole square dx. Now let x plus 1 is equal to u. Let x plus 1 is equal to u. So this is equal to 1 is equal to du divided by dx, which implies that du is equal to d of x. Now putting the values in this equation, you will get du 1 divided by 5 minus u square under the root plus 1 plus x is equal to u 5 minus u square under the root du, and I can write it as I can so this is equal to 1 divided by 5 minus this one du plus, I can write it as this one 5 minus u square. This is equal to 1 by 2, and when this become in numerator, this will become minus 1 by 2 u and du. Here I 2 multiply here and divide 2 here. So when I take and also multiply with minus and here also minus, so this will become, when you take the integral of this one, I can write it as under root 5 square minus u square du plus 1 divided by minus 2, and this is equal to f of x, and this is f prime of x. So I can write it as this is f of x and this is f prime of x. Okay, so this is equal to, the integral of this one is equal to sine inverse of u divided by under root 5. So integral of this one is sine inverse of u divided by under root 5, and the integral of this one, this is equal to minus 1 by 2, and this is equal to 5 minus u square minus 1 by 2 plus 1, and here also minus 1 by 2 plus 1 plus c. So put the value of u, which is equal to x plus 1. So sine inverse of x plus 1 divided by under root 5, and after solving this one, and this is equal to 2, and this is equal to 1 by 2, and this is also equal to 1 by 2. So this is equal to minus 1 by 2, and 5 minus, this is equal to minus 1 plus 2 divided by 2, and this is equal to minus 1 plus 2 divided by 2 plus c. This will become, sine inverse of x plus 1 divided by under root 5, and minus 1 by 2, and this is equal to 1 by 2. Okay, and this is equal to 5 minus u square 1 by 2. This 2 is cancelled with 2, and this is equal to, put the value of u, which is x plus 1 minus 1 5 minus x plus 1 whole square, and this is equal to 1 by 2. So I can write it as this is equal to sine inverse of x plus 1 under root 5 and minus, and when I simplify this one, 5 minus x square minus 1 minus 2x 1 by 2. So this is equal to sine inverse of x plus 1 under root 5 minus, so this is equal to minus 4 minus x square minus 2x 1 by 2. So this is equal to sine inverse of x plus 1 under root 5 minus under root minus x square minus 2x plus 4. So this is our final answer. In next video, inshallah, we will discuss integration by parts.